distribution. So, as you know, the probability of all things happening, all the probabilities add up to 1, right? Okay. So what we're doing today is just like organizing all those probabilities into a chart, and we can do stuff like learn how to find the variance and the standard deviation and the mean and the expected value and all that stuff. All right. Hopefully, I'm pretty sure most of these equations are on your formula pack. Yeah? Okay. Here we go. 3 terms. Random variable, discrete random variable, and then continuous random variable. Right? So a random variable is just a some type of quantity whose numerical value depends on chance. It's probability. Right? And usually we use the capital letter X for the random variable, or some type of capital letter for that random variable. Okay? The difference between discrete and continuous. Does anyone know? Anyone done probability before? What do you think when you think continuous? Keeps going. Yeah, kind of like rational numbers, like kind of like a number line. You're thinking on a number line, right? So let's look at continuous first. When you think continuous, think of something that could be on a number line or something that could be measured. Yeah. So in other words, it has all positive values. So maybe not integers, maybe like full numbers. So it's all positive values in some interval. So like a range of possibilities that can happen, like height and weight and volume, stuff like that. Okay? As opposed to discrete. Discrete is just like count. 1, 2, 3, 4. Okay? So a discrete random variable are the variables that you could just count. Right, as opposed to being measured. So an example of this would be like number of houses, right? Houses, number of defective light bulbs. That one likes to come up a lot, right? Marbles, how many magazines did somebody pick out? Where again, continuous is like volume, weight, okay? Yeah. The one that we're going to focus on today is discrete. Right here. So that's going to be random variable. Yeah? Okay, so a little bit new notation. Yeah? Today we're going to talk about pixies. Yeah, fairies. Yeah. Here we go. The probability distribution of a random variable is listing all possible values of xi, where this is the discrete random variable, and then it can happen so many ways. Like you could buy 1 house, you could buy 5 houses, or something like that. So x would be like the number of houses you would buy, and then xi would be all the number of the different possibilities that will happen, and then you just calculate the probability of all those things happening. Okay, so the probability of any given event, like pi, instead of like pi, lies between 0 and 1. Therefore, if you take the sum of all the possibilities, right? If you take the sum of all the possibilities starting from 1 to however many possibilities there are, that should always equal 1. Say it again? You remember this? A little bit? You did this where? Sophomore year with, so you did math analysis. Yeah. This was a math analysis. Of course you had math analysis. Yeah. Oops. Yeah, so again, all that says is if you add up all the possibilities, you should equal 1. Okay? Remember, nothing too hard yet. It's just terminology. Alright, so once upon a time, A magazine store recorded the numbers of magazines purchased by its customers in one day. 23% of the customers purchased just one magazine, 38% purchased two, 21% purchased three, 13% purchased four, and 5% purchased 5%. So just 5. Come on in. Oh boy. Okay, hang on. Let's pause this real quick. Okay, so sorry, not 5%, just purchase 5 units, right? How would you describe the random variable? What would that be for X? Number of shirts? What are we talking about?
Number of
Yeah. Yeah. So X equals number of magazines purchased. Yeah. Okay. So let's make a random variable probability table, right? So little x is going to be like the number of magazines that could have possibly been purchased. So we got 1, 2, 3, 4, and 5. Actually, let me move this over just a little bit. There it is. I'm going to do the total at the end. Yeah. So that's the possibilities can happen. Then underneath it is the probability, and the way you write it is the random variable equals little x. Now, the probability of purchasing one magazine was 0.23. 2 magazines was 0.38, 0.21, 0.13, and 0.05. Okay? Okay. Guess what happens when you add all that up? Yeah, dude. It is 1. Yeah. Yeah. That's a probability table. So when you're thinking about writing, if you're going to do a probability IA, you probably want to put a random variable probability table. Makes it a good, fifth of your paper. Love it. Yeah. There you go. Yeah. Okay. Spike graph? We don't do spike graphs very often. Here we go. 1, 2, 3, 4, 5. And let's go by 0.10s. So 0.10, 0.20, 0.30, 0.40. Yeah. And so a spike graph would just be the graph of each thing. So 0.23, 0.38, 0.21-ish. Yeah, 13. And then, sure. Yeah. Okay. Okay. So let's connect this to what was that? All can't remember. Here we go. All right. That contains 4 red marbles, 2 marbles total. 6. Okay. 2 marbles are randomly selected without replacement, which is key. So if x is the number of reds selected, find the probability distribution of x. Yeah? It would help to draw the, I can't remember what it's called. The tree diagram. Thank you. Oh my goodness. Here we go. So the probability that your first marble is red. The words escape. Probability first marble is red. 4 to 6. Yeah. Yeah. Probability that your first marble is blue. 2 to 6, right? 4 plus 2 is 6. There's blue. Yeah. Okay. These two break off. Probability that your second marble is red, given your first marble is red, is yeah. 5. So probability that your second marble is blue, given your first marble is red, obviously 2 out of 5, because that has to happen. one as well. Yeah? Okay. Here we go. Probability that your second marble is red, given your first marble is blue. And the probability that your second marble is blue, given your first marble is blue, is 1 out of 5. Yeah? Okay. So our X, right? Our big X is going to be the number of reds selected. Right? So our little x is going to be either 0, 1 red, or 2 reds. Yeah? So we need the probability of all those things. Fine. Here we go. The probability that x is 0 is going to be picking the probability that the first one was blue and the second one was blue. How do we do that? Yeah, so 2, 6 times 1/5, right? Which is 2 over 30, which is 1 over 15. Gorgeous. Okay. Probability that x equals 1 means one of them has to be red. So either the first one is red and the other one is blue, or, so we add it, the first one is blue and the second one is red. Okay. Okay. So red 1, blue 2. I can't see the chart anymore. So picking the first one as red was like 4 to 6 times 2/5 plus 2/6, right? Times 4/5, which I'm pretty sure is the same thing. 8 over 30 plus 8 over 30. So that's 16 over 30, aka 8 over 15. True? True. Okay. Last but not least, the probability that x is 2. So both reds. You look at probability of red 1 and red 2. Which is 4 out of 6 times 3 out of 5. Is that right? Yeah. 12 out of 30, which is, I'm just going to divide that by 2. 6 out of 15. Here's why. 1 plus 8 plus 6. 15. Yeah. If you total this up, this should be 1, or 15 out of 15 if you add them all up. Yeah? Okay. So we're just creating the random distribution of, oh yeah, that's easy. Okay. So making our table. We have little x, then you have p of big X equals little x. So 0, 1, 2. The first one was 1 over 15. Yay. And then 8 over 15. And then 6 over 15. Or 3 over 5, whichever. Yeah? Yay. And just to reiterate, that box at the bottom, the sum of the probabilities is 1. Thanks. In other words, another way to write it, the sum, of px equals x, 1, So far, so good. Okay, here's how you make money. Ready? Go ahead and build yourself a casino. Yeah, go ahead and build yourself a casino. Because as you saw in your dice game, casino always wins. Yeah. You want to sell it? Is he selling it? Most people. Yeah. I don't know. I know like there's professional poker players out there. When I was student teaching, my teacher's husband was a professional poker player, but he was never home, so they got divorced. It's really sad. Anyway, but he made a lot of money. No, especially since gambling is very addictive. Anyway, here's how you make money. Yeah, expectation, right? So, take the notation e to the big X. E to the big X is just like the average that you would expect from winning or getting what you want, right? So we've seen this notation for mu, right? Mu just means something something. Mu is the mean. Have you seen that in the statistics? Mu is the mean, right? Okay. It's the mean value of X. Then you have the particular number of outcomes. P represents the possibility of that occurring. So it's the probability of X equals little x occurring, right? And then your return your random variable is what you want to happen. Okay. Note that the mean, right? The mu is the mean amount you would expect to win over a very long run of turns. So this is what Matthew was talking at, right? It was getting at if you keep on playing, what would happen to your like what would you expect to play? In other words, like what happens as you tend to infinity, right? As you go towards infinity, what would happen? Would the house keep winning? Probably, I think. Yeah. Their margin might get a little bit smaller, but they'll still be a little bit ahead. Yeah. Okay. So consider this game. You have to pay $5 to play this game. Just $5. That's it. You have a chance of winning up to $8. What? That's like a 100 and some odd % return. Awesome. Well, if you're spinning a rotator, you get 1, 2, 3, or 4. If you get a 1, you get $1. 2, you get $2. 3 is $5, and 4 is $8. Yeah. So what would you expect to win in if you just had one shot at it? Right? To do this again, all you have to do is multiply the probability times the how much you'll win, and you'll get the expectation. So, what's the probability of spinning a 1? Yeah, so it's 1/4 times $1, right? And then 1/4 if you spend 2, and you get $2 plus 1/4 of $5 plus 1/4 of $8. Okay, and if you were to calculate that, turns out it's $4. So, would you recommend this person to play this game? No. Even if you won, you're gonna get less than what you paid for it. Most likely. Yeah. So much fun. What happened? It's okay. Sorry. I wanted to see what you got, but what you got. Yeah. Okay. All right. Here's a fun one. I like it when they throw these problems out. This is super easy. Because they tell you some of the probabilities. You have to find A and B. But they tell you that the expected return is a 3. What do you think? pause it. So, keep working if you're still working. Here's one of the equations, right? Since we know that all the probabilities have to add up to 1, you just have to add all these together, right? And then your first equation would be like 0.1 plus A plus 0.3 plus B equals 1. So A plus B equals 0.6. Yeah, that's one equation. Yeah. The second part is from the expected value. And I know we did 1/4, 1/4, 1/4, but that was the probability of doing it last time. For these ones, it's not as clear, but this is what you multiply your expected value to. So you go 0.1 times 1 plus A times 2 plus 0.3 times 3 plus B times 4 is equal to your expected, which is 3. You'd end up with 2A plus 4B equals 2. Yeah, that's 2. And I would reduce that. So divide everything by 2. A plus 2B equals 1. And we could do row reduction, but why? Here's A is 1 minus 2B, so if you plug that into this side, 1 minus 2B plus B is 6. So B, or 0.6, so B has to be 0.4. Yeah? There's one of them. Now plug it back to this side. A is 1 minus 2 times 0.4, which is 0.8. So A is 0.2. Yeah. Did you get close to that? Is that where you guys were heading? Yeah? Okay. 2 variables, 2 equations. Good old systems. Alright, here you go. Last thing. Ready? Okay. There is a very, very, very long and complex way to get this formula. I'm just going to give it to you because I'm pretty sure it's on there. Yeah? Okay. To find the variance, you know what the difference between variance and standard deviation is? Yeah, variance is standard deviation squared, or standard deviation is square root of variance. Yeah? Okay. Got it. Awesome sauce. Here we go. I like, out of all those solutions, I like this one. I like that version the best. Because that's pretty simple to figure out. Mu is the standard deviation. No, sorry. Mu is the expected value. So you just find the expected value. And then you just find all of the probabilities times the x squared this time. So like instead of what we did before was just like the p times the x, it's p times x squared this time. Yeah. And instead, it's not the spare root, it's the square root. Yeah. Okay. So let's find the first thing, the mu. Okay. The mu is the expected value. Oh, sorry. Next one. Here we go. The mu is the, okay. Here we go. The mu is the expected value for this thing. So, I'm just going to go ahead and skip the 0. Is that okay? Yeah. 0 times 0 is nothing. All right. So from before, this is the magazine one. So this is 0.23 times 1 plus 0.38 times 2 plus 0.21 times 3 plus 0.13 times 4 plus 0.05 times 5. So you got that calculator? Yeah. You left it? Alright. I have the answer, I just want to make sure we came up together. Same thing. 2.39? That's what I got. Was good? Okay. Okay. So save that, because we're going to need that in the formula. Okay? So second thing, find the standard deviation. Find the standard deviation, find the variance first. Okay? Okay. So finding the variance. Var of x. Yeah? To do that, we need, well, the formula is Pixie squared minus mu squared, which we have mu squared. So let's find Pixie. Yeah. Okay. To find Pixie, it's the probability times the x squared. So it's going to be 0.23 times 1 squared plus 0.38 times 2 squared plus 0.21 times 3 squared plus 0.13 times 4 squared plus 0.05 times 5 squared. Got a number for me, Abby? So 97? Yeah, sweet. All right. So 6.97 is what we got for that. So finding the variance, that's easy. Gamma is the variance. So yeah, var x. Is it gamma? What is that? No, that's not gamma. That is sigma. That's baby sigma. Yeah, sigma squared. So the variance is sigma squared. That's just going to be 6.97 minus 2.39 squared. Which is 1.2579. Yeah. Now that's sigma squared. So to find the standard deviation, it's just sigma square root both sides. And I got 1.1216 for the standard deviation. Is it good? Yeah? Okay, so something's familiar from loss? And better?